we will be able actually to master the work with the T-SQL transactions. So let's go on from the beginning and just briefly and let's say quickly considering the content of this working with the transactions, the T-SQL transactions here meant. The actually the first property that a transaction has to conform its content to is the asset, the atomicity, consistency, isolation, and the durability, which are actually properties a transaction has to fulfill in order to say that the transaction is secure and is guaranteed. Secure in terms of security and guaranteed in terms of information assurance. Secure and security means it will not be broken, it will not be interfered, it will not be actually hacked. Secure. Information assurance in terms of it is, let's say, consistent and it will be fulfilling what has been meant for, what it is transmitting, what it has to transmit. Information assurance, data assurance. Great. Actually, briefly, the context of the atomicity. It's a scenario via which we see a multitude of queries being executed together. We see a list of tasks to do, as per the example we are taking here, the ATM, but whatever. We see a list of tasks to do, and all of them, they have to be either run together or cancelled together. Means either all of them, they have to be actually executed, or they do not. They will not be actually executed. Means admit them all or cancel them all. There is no other option. There is no in between. Yes, we execute this part or this part. No, otherwise you are breaking the atomicity fact. So the first consideration of the context of the atomicity, the properties that the transaction has to obey to, is the atomicity. And here we see list of queries belong to one transaction. Remember this phrase, list of queries belong to the same transaction. Either admit them all, execute them all, or cancel and roll back all of them. Atomic. They have to be seen by the system in question as atomic behavior, atomic query, atomic task to do, atomic process. Example of atomicity here, we are generating a transaction. That has a body, and the full transaction actually it would be executing two queries in this example here. So we have actually an entity generated already, and this transaction will be populating that entity earlier created. So we have two queries, either to execute them all, or the transaction fully will not be. It will not be actually executed. So the transaction here in question to fill those two queries, those two inserts, or to fail in executing those two inserts. This is a real case. Good. Second property is the consistency, and via which we see transaction finalized fully, executed fully. Means from the beginning, because the transaction, as we said earlier, it might have a list of queries, and those queries, they have to be either executed fully or they have to be rolled back and cancelled fully. No other option in between. We cannot segregate. The scenario says the transaction has a list of tasks to do, and those tasks, they are atomic, and they have to be consistent, means finalized. If they are not finished, we are not obeying to the consistency fact that a transaction has to obey to. What does it mean? It means actually we can find a list of queries belonging to a one transaction not finished. Yeah, absolutely we can, because as per the example of the ATM, if a shortcut, an electrical shortcut has happened in between when a customer is receiving money, what happens? yeah, the remainder of the tasks, the system will fail in doing them. If he reaches to deliver money and he did not update the system, so there is a failure. And inconsistency, actually, it would this example of the shortcut, electrical shortcut, is an inference. Is a sort of something happened in between when the transaction is being executed. Yes, it's an inference. And an inconsistent, let's say, transaction or inconsistent task. Does it mean that the system will fail in all cases? No, no, because there might be actually an interference. The transaction has stopped, and later on it will continue. This is not consistent, yet the system will not, because this is not consistent, but the system will continue at the end. It will not fail. After 1 hour, after 1 day, after one period of time, it will continue. When the system has been fixed, or let's say the work has come back to a normal situation, so the transaction will continue, will finish. Thus, it is not consistent. There were an interference, yet the system did not fail. The process will continue at the end because the process will be finished later on. Consistency, second property. The isolation of a transaction is a request via which we see a transaction isolated from the external environment, from the constraints that might be actually seen in a given environment. So any requests to stop a transaction and execute something else, it will be blocked. The transaction has to be completely isolated from the external environment. Once started, it has to be finished. When I come back to the example of the inserts here, once this transaction, this procedure that defines this transaction has started, those two inserts have to happen, have to be finished, have to be executed. Otherwise, the system will not execute this first insert, then goes to execute another transaction and comes back to execute this insert. No, he will not. The system either to execute both or no, both consecutively without delay. Why? Because this transaction has to be from the beginning set as isolated. Isolated in the sense of blocking all the other transactions or all the other requests to stop the execution of the content of this transaction. So it has to be finished first, then it will go to another process. Isolation. The properties we describe right now, the consistency, the atomicity first of all, then the consistency, and also the isolation. They are three security views, and this three they are guaranteeing that the transaction will run as perfect as it has to be. And since they are positively described, they have to be continuously set for all sessions in a given system. When you talk about the example of the ATM, so the atomicity of the requests, the queries, consistency of their execution, and isolation of the session, it has to be valid for all the sessions, the users, all the requests. It has to be seen atomic, consistent, and isolated. All the requests. So user number one, or customer number one, customer number two, customer number n, administrator, normal user, bank agent, whomever, since they are using the same service, they have to be their requests. They have to be actually executed in an atomic way, consistent and isolated. Here we are talking about the durability. Here we are talking about the durability. And thus, we guarantee, this is an information assurance, we guarantee the best behavior, that the transactions would be actually guaranteed, would be trusted, or the requests recorded in the system, they would be actually guaranteed. Durability. Transactions modes, they are one of the methodologies via which we guarantee that the transaction or list of transactions or whatever transaction in question is going to be accomplishing the request perfectly and specifically. Perfectly means it will do specifically as per the request. Transaction modes will do the control here. Transactions modes, they are a list of ways how a transaction would be admitted versus the system. The system you are talking about, the DBMS, database management system, the engine in question. In our example, in our context, in our book, we are describing the SQL server. The transaction mode means we are going either to admit implicitly or explicitly, or we are going to cancel what has been sent as a query or list of queries. We have four modes mainly. If we are talking about a transaction that it is built on top of one query, so we are talking about an auto commit transaction. The mode is auto commit because the system will automatically admit that if it is one query based transaction. If it is one query based transaction, the transaction has only one query, one select only, for example. So, or one insert only, one update only, truncate one transaction, one query. So the system will automatically commit. The system will automatically commit the process in the transaction in question. Second mode, transaction mode, which is the explicit transaction. There is no order here. There is no order. It is a matter of defining the transaction modes. It's not first, second, third. No, because whether you are going to build an auto commit based transaction or an explicit transaction or an implicit transaction or something like that. So it is not the first, the second. No, it is not a count. It is a count, but it's not an order. It's not sequential. Explicit transactions, they are transactions that do have actually a body scope. It's a blueprint. It's a code that has to be executed. It's a list of queries to be executed. Whatever, 1, 2, 3. Mainly, if it's not one, it's two or more queries. They have to have actually those transactions, those types, those modes of transactions. Those transactions, they do have actually a beginning and an end, and they have to be explicitly set to be either committed or rolled back. Means after the execution, either to commit or to roll back. The same scenario when we define the implicit transaction, we are talking about a transaction that has to be started right after a commitment, or let's say a commitment, yes, rollback or commit mode. Immediately, actually, it would be actually implicitly started, a transaction that would be implicitly starting after a commitment state, let's say, and it has to have actually explicitly terminated with either a commitment, either a commit or a rollback. Commitment here, when we say commitment, we're going to commit or to rollback. Even the rollback is a commitment. because we are going to make the system save the changes, commit, or to make the system cancel the changes, rollback. The fourth mode, which is a little bit complicated than the others, and it is much more utilized in real cases, which is the batch scope transactions, where we see actually more than one uh, commitment in the same transaction be set. But here we are talking about a certain type or category of transactions to be seen only in this transaction mode, which is the mass transactions, the multi-active result sets transactions. Those are transactions that they do have actually more than one command to be uh, executed with different queries. Command number one with different queries, and command number two with different queries, command number three, and so on until command number n with different queries. The mass transactions, they do not have actually a chance to control the commitment for separate commands. They would actually either commit all or roll back all. Why? Because each command would have a different result, a different output. And there is a secret here, actually, why we are classifying them based on either mass transactions or non-mass transactions. The batch scope transactions, they are actually either mass or non-mass. Why? Because for the non-mass transactions, we may have different commitment from within the body of the transaction itself using save points. Let's go one step further. For the non-mass transactions, actually, we are talking about specific usage of the commitments. We are able to use different commitment states, let's say commitment modes from within the same transaction body, and this is due to the save points. Means because of the save points, we will be able to make a commit and make a rollback and make all as per the request of the transaction, no, as per the request of the process. We may have two commits, we may have a commit and a rollback, we may have two rollbacks, we may have more than that, not only two, from within the same transaction. This is due to what? To the use of the save points, because we can roll back to a specific point, we can roll back specific range, and so on. Save points. What are save points? Save points, they are time frame points, time-based points, via which we can indicate a cropping point in the transaction life cycle. Okay. See, here we have, see this in this slide here, slide number 15, we have a transaction that starts here. It ends here in slide number 16 in this level. Let's say commit here. Okay, what's the problem here? There's no problem. What we see here is that we are going inside the body. So it means slide 15 and 16, it only shows us one transaction. But in between here, we are seeing the slide 16, we are seeing a rollback query, a rollback statement to a position named save point one. We're going to roll back the transaction until this point. What is this point? This point, if I come back to the slide number 15, here it is. We are generating a save point. Inside the transaction, there is a save point named save point one, which is this one, which is this save point one. Is the same. So we are rolling back until here. What does it mean? Means that all of those statements what came in before, they are being rolled back. Those queries here, those three queries here. It's one query only, but It is a nested compound query. This happens only why? Because this transaction mode is not a mass. This transaction is not a mass. We are seeing queries only, query, 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 and still query here, query here. So only queries. So we can neglect, we can commit, we can roll back specific queries. We can commit specific queries, we can roll back specific queries. There is no issue at all. This is a non-mass. Why? Because those queries, they are not specifying different results, multiple or multi-active result sets. They are actually standalone queries, yes, but they are not specifying multitude of results to be considered differently. Why? Because we can play in the order, we can modify, we can neglect, we can stop in between. There is no issue. Let's compare, to make you understand more, let's compare this transaction here, what we saw here in this transaction, this non-mass transaction. Let's compare to this transaction here, this mass-based transaction. At the beginning, we are having actually, we are creating, this is actually due to the .NET usage, because we are defining a thing inside the .NET. We are using C# solution, and we are using the .NET. What does mean .NET? It means we are using the Visual Studio with the C# programming language, and we are linking to the SQL server using the IDE here to Visual Studio. And we are passing queries through, let's say, data set or data reader based on the scenario here, whatever. So we are generating a first command. This command actually is connected using a connection, and the connection is pointing to a specific data base or data source, and we are specifying that we are going to use the multiple active result set feature. Means this would not be the unique command inside the transaction that we are going to define right now. So now we are having this command that has those queries. Let me go to the next slide. Yeah, here we are defining a second command that has a different, let's say, query. Okay, we are starting a transaction. We are giving it a name. See here, we are creating a transaction, and we are giving it a name, user defined, and we are linking the command 1 and then command 2 to the same transaction. Run, same transaction. So the same one transaction has to carry out the two commands, command 1 and command 2. Next slide here. When we try to execute, we will have to execute the command 1 separately, and we have to execute the command 2 separately. If we try to commit or roll back, what to commit or what to roll back? It's the transaction. It was the problem. There is no problem here. The point is that it is one transaction only, but we are having inside two different commands that each of them has a different result to be brought. Can we commit this one and roll back this one? No, absolutely, because both of them, they are in the same transaction. So either to commit the transaction or we roll back the transaction. How we subdivide them? You cannot. You cannot roll back command 1 and commit command 2. They are both in the transaction. So we commit the transaction means we commit both. We roll back the transaction means we roll back both. Whatever happens with this transaction It happens to both. Both what? Both commands. This execution here has happened. This execution of this transaction, actually, this is the end of the transaction here, but this execution of this transaction has happened in a body of a try block. This is security measurement. This is security measure to control the runtime issues. To control the runtime issues, because to make a select or to make an insert, what a user can input what an end user might input. Actually, this is in runtime error during the runtime only, might cause an issue, might cause the transaction to fail. Yeah, during the runtime, and if the transaction fails, so the system would fail. Thus, there has to be control of that. So what the user has to input at the end of the day during the runtime has to be either admit, controlled. Okay, in our case, if there is any issue, there have to be an alert. The system will not fail. The system will not fail. The system will continue if there is any issue in runtime. How? This try literally said it would try to execute this block here up to here, up to here. If yes, validated, خلاص. Okay, that's all. It's done. If any issue happens in this block, if any issue, it will not be run, and this catch block will be run. This block here, from here until here, would be run, which is the catch block. So if any runtime issue happens, the catch block would be run. Great. So those transactions actually with their different modes here, actually this is an example of a mass transaction, which is a batch scoped transaction. Great. So those transactions, they are actually to be run in real field, which is, let's say we take the example of the web, and the web actually, we are talking about the internet as for an example. The users of the internet dedicated to, let's say, social media application, they are thousands and millions of users. So the huge number of the requests at the same time might cause the application to fail in replying correctly. Not to fail to run, it would run, but replies would be falsified. Somehow the system will fail in replying correctly. There are technically described issues that might be happening due to the runtime, let's say, complexity, runtime, the number of usage requests per time, and so on. I asked you the question at the beginning that the phantom red, what does it mean? It is one of the issues that happens on top of the transactions execution on during the runtime. It's due to the number of usage and due to the number of the requests, no more, no less. So those issues here, this dirty red, non-repeatable red, and the phantom red, they are errors. Happens to a transaction in runtime, no more, no less. You have to recognize them all. They are available in your book. So to countermeasure those issues, we have an isolation level to set. To avoid those issues. And the isolation level, it is one of the scenarios you have to obey to, based on the question or based on the request. You cannot apply all, and you cannot use any. It depends on the context. So I'm going to explain just one of them, which is the serializable, I'm going to say. The serializable, actually, one of the contexts here, we know that transactions, as per the example of the transaction modes here, if I take the example of the batch scoped transaction and specifically the mass transaction. Is it small transaction or very short transaction? No, it might be very long. It might be adequate, short like the example we saw now. 2 queries only, 2 commands only. And at the same time, it might be very long transaction, and that requires time to be executed. How many users of the transactions that transaction, the bash scope transaction, mass transaction in the system are the users or the customers. So if there is an update and an insert and so on in that transaction, user one is asking for an update and he's executing that transaction. If user two asks that transaction, what he will see the updated transaction, the updated content or the old content. He will see only old content. Why? Because the serializable transaction level or isolation level will cause a deadlock to the entity in question. Thus, any user of the entity on top of the transaction, he has to finish his transaction in prior that another user, second user, or other users will be able to use the same entity or same resource. The isolation level in this transaction, serializable, will cause a deadlock. And the deadlock is a context of locking the transaction resource for the specific transaction. It will not be used by another. There will be no other inserts. There will be no other updates until this transaction is being finished. Serializable. It's one of the very famous and very sensitive isolation levels because in some scenarios it causes time latency. So here it's very successful. The serializable yes, isolation level, because it will guarantee that the transaction will be updated by one person only, and then after the other one, and then after the other one. So it is very secured and very guaranteeing the data manipulation. Yet it is time-consuming process. It is a time-consuming process when you compare to the other modes. Sorry, to the other isolation levels. The serializable, whenever it locks an entity from being used, so it will consume time. It will need time to let the other users reach the same resource. Serializable isolation level. Here, the example we are seeing here is the context of the serializable isolation level. It's a transaction. We are generating a transaction at the end of the day, but we are setting at the same when we define the transaction, we are setting an isolation level. Here, this is an example. We are setting up a transaction. We are creating a transaction which is having a body. Here it is. This transaction that would be created, it is to be isolated with the isolation level serializable. So the deadlock would be actually executed on all the resources. Here we are seeing this DBO test and this DBO test again. So the users of this DB test, so this test entity, they have to wait for this transaction to finish in order to be able to use this test again and again and again. So this is a process that consumes time. See here, wait for delay, 10 seconds. So it is a process that secures the entities very perfectly. Yes, it's very perfect. It's very strong isolation level, yet it is a time-consuming process. It is a time-consuming process. See you next class, inshallah. I'll take the attendance. If you hear your name, just say yes, please.